Yes, hello my dear friends, welcome all of you to the ISRO previous year question solution analysis. My dear friends, in this session we will discuss the ISRO previous year question that has been asked and we will share their detailed solution, and at the end of the session you could be able to analyze that yes, what type of question is going to ask in the ISRO. But before starting the session I want to tell you that you have to be prepared very well for the ISRO, then only you could be able to crack that exam. Because you know ISRO that is post for the scientist, so ISRO want that type of student who can think like a scientist. So if you solve the question later on, as you move forward you will see the different questions, you will find that they will make you like a think like a scientist. If you are not able to thinking, then really my dear friends, it will be little bit tough to crack that exam. So you have to be think like a scientist and you have to develop that potential. If you don't have, you have a time, read the concept and try to think different possibilities that can be framed on that concept, then you will easily crack that exams. Let's start the discussion and see which type of question is going to be asked. Lot of question I have to discuss in this session my dear friends. And one more thing I want to tell you, that session will be little bit longer session, because you know ISRO question are there, 85 question are, so it will be take longer time. You have to be just keep a patience and see the solution all the question and see how you have to be think on the questions, right? So let's start with the first question. Yeah, a few initial few question are easy, but as you move forward you will get difficult questions. So that question is easy my dear friends, anyone can do that, no problem I think. So that is the first question on your screen. A beam is subjected to uniform load WC per unit length, right? WC per unit length, and MA, VA and VB are the reaction as shown in the figure. The expression for shear force and bending moment is given by, and that option you have my dear friends. So that is the question of the strength of material, and simply from the SFD and BMD my dear friends. So simply what you can do here, simple take one section there, right? Take one section, suppose that take a section x distance from that one, this is the x. Now I will ask what will be shear force about xx, that is our section xx. Let's assume xx section is there. So what will be shear force my dear friends? What will be shear force? We can say there is a one force VA is acting, so it will be VA in the upward direction. You are moving left to right, upward is taken positive, right? In SFD BMD if you are moving left to right, then upward shear force is taken as positive, downward is negative. That is the concept, simple. So and how much total force? Sir, this is WC Newton per meter, no sir. So in the x meter how much force is acting? Sir, it will be WC into x, right? So it will be, but in the downward direction, so it will be minus WC into x. So shear force will be VA minus WC into x, that is the shear force. Simply we can go through the option, we can say either it will be answer B or D. A and C can't be option. Okay, now think about the moment about xx. What will be moment about xx section? Simply we can say, sir, this is VA at a distance x, they will try to rotate in which direction? Clockwise. Clockwise is taken positive my dear friends, so we can say, sir, VA into x. Now there is a one couple, MA is acting, this is also in the clockwise. Left to right, clockwise is always positive, left to right, clockwise is positive, left to right, upward force in the shear force diagram is taken as positive. Okay, so VAX. Okay, and MA, this is here you can see one couple concentrated movement is there, MA, so it will be positive, so simply MA. But sir, what is that force? W Newton per meter, WC in the x Newton, how much force will be? How much force? So we can say, sir, WC into x. But what is their line of action? Center pe, sir, it will be at the center. So WC into x, and that distance will be what my difference, x by 2. But they will try to rotate in clockwise, anti-clockwise. That force will try to rotate in the anti-clockwise direction. Left to right if you are moving, it will be negative. So simply we can say, sir, it will be WC into x by 2. And by solving that, sir, simply I can say moment about x-axis is coming out to be MA minus of VA x minus of WC x square upon 2, and shear force you have get. So according to the option my dear friends, Bombay cannot be answer. The correct answer is what? D for Delhi is the right answer, and we will get the answer. So it was a very basic question. If you know the SFD BMD, you could be able to solve. There is nothing like you have to be think like a scientist, but yes, in the upcoming question you have to be think like that. I am coming on that next question. So my dear friend, that is the next question has been taken from the machine design. That question has been taken from the machine design, but yes, little bit good question it is also. See my dear friends, and just use the concept, and you can simply say the aptitude, like you have to just think like aptitude, you could be able to solve that question very easy. See the question: a weld with a triangle cross section as shown below is to be the produced on a steel workpiece by shielded metal arc welding. Here which type of arc welding is? Shielded metal arc welding is going to be performed. Operation using a steel electrode. Okay, if 24 volt power supply is used and the welding speed is given 12 mm per second. Okay, what is the current needed? Assume the efficiency is 80% and the specific energy melt steel is 8 joule per mm3. So what is the current needed? What question you have to be calculate? In this question, sir, I need to calculate the I, and yes, I need to calculate the I. How I can calculate? Now start thinking how I can calculate. Sir, in the question, sir, here we can see voltage is given, na sir? Haan sir, voltage is given. So simply I can say, sir, P equal to V into I. Yes sir, I can say. Sir, anyhow, in the question voltage is known, I have to be calculate I. If anyhow I am able to calculate the power, then I will get the I. Yes sir, I can. But how I can calculate the power, sir? How I can calculate the power? So my dear friend, just think. See there, that is the triangle now, but joint section it is. So what will be area of that one, my dear friends? What will be area? So simply we can say, sir, half base into height. So what will be their area? This area. Simply by solving that we can say area will be area of that one half B into H. So simply we can say total area 1 by 2 into B is what, my dear friend? That is given 5 and that is 5. It is coming out to be how much? 12.5. You can say mm square, right? Okay. Now coming to the next concept, next thing, area you have get. Sir, now tell me what will be the volume of weld matter deposited per second? That is the area, and see that is the area, fine, that is, and you can see here that welding speed is given. What is welding speed? My dear friends, in the question welding speed is given how much? 12 mm per second. Means in 1 second they are going to weld in the 12 mm. 12 mm distance is going to be weld in 1 second. And the area is what? 12.5 mm square, right? Now my dear friends, if I will ask what will be the volume of metal deposited per second? Volume of metal deposited per second. Metal deposited per second. Tell me what will be, my dear friends? So we can say, sir, area into velocity, right? Like a discharge. We can say the discharge. So what will be area into velocity? So area into velocity, weld velocity. So it is coming out to be how much, my dear friends? Sir, 12.5 into 12, it is coming out to be mm cube per second, right? This is mm square, and this is mm per second. It is coming out to be mm cube per second. So this is the volume flow rate, sir. I get the volume flow rate. Now see, my dear friends, we can say that is the volume, means in 1 second how much metal is going to be melted out. In 1 second we can say, sir, 12.5 into 12. By solving that, how much it is coming out to be, my dear friends? It is coming out to be 150 mm cube per second, right? Okay, mm cube per second. That means in 1 second that much amount of metal is going to be melted out. That much amount of metal is required. How much? 150 mm cube. But sir, see there, how much energy is required? Here we can say the specific energy to melt, means to melt 1 mm cube, to melt 1 mm cube you need how much energy? Sir, 8 joule. Okay, to melt 1 mm cube you need 8 joule of energy, my dear friends. So tell me, to melt 150 mm cube, how much energy is required? Yes sir, that is the simple, you can say, mathematics, aptitude, nothing else. So we can say, yes sir, here specific is given, na, my dear friends. So okay, I can, some student think, sir, I don't know what is the specific energy. In the option we can say the energy required to melt per unit volume, energy required to melt per unit volume is known as a specific energy. So this is given 8 joule per mm cube, and in 1 second how much is going to be melted out? So we can say 150. So I can ask energy required per second, or this is called power. Energy required per second. This is also known as what, my dear friends? This is also known as power. Sir, it is given by, simply I can say 150, and specific it is given how much? 8. It is coming out to be 150 to 8. How much it is coming out to be? Sir, 1200 joule per second. That means 1200 watt is coming out to be. Yes sir. Now come to the, again see the question. Sir, in the question it is mentioned that Assume the efficiency is 80%. Means, sir, if you talk about shielded metal arc welding, I am coming to you. See, my dear friends, this is the one of the object, and that is your electrode, and your electrode is connected with the some terminal like that, and this is like that, huh? So actually energy required is how much? 1200 watt is energy is required. That is coming from that one, huh? But the efficiency is given here how much percent? 80%. Means whatever energy is coming, there only 80% is going to utilize for the heating purpose. Rest 20% what is happening, my dear friends? Whenever the coming into the arc could be possible going to the in the form of radiation, going in the form of convection or radiation. So only 80% is reaching there. But you required how much? 1200 watt required. So how much you have to be supply? How much you have to be supply? Obviously more than 1200, no, sir. So what will be efficiency, my dear friends? Simply I will ask what will be efficiency. So we can say, sir, efficiency will be useful power upon electric power. Useful power upon, we can say, supply power, or whatever is electric power, whatever you can say. Electric power. So actually useful power that you have to be get is coming out to be how much, my dear friends? It is simply we can say, sir, if need the electric power, what will be electric power? Electric power or supply power, whatever. Simply we can say useful power 1200, and upon efficiency, efficiency is given 0.8. By solving that, how much it is coming out to be, my dear friends? 1500 watt. Means you have to be supply the energy how much, my dear friends? 1500 watt. So can you get the power? Yes, sir, I have get the power, sir. Yes, sir, I have got the power. Power is how much, sir? Electric power is coming out to be 1500. Can you know V is equal to I? V and I, power equal to V into I. So can you calculate I? Yes, sir, I will calculate. By solving that, we will get velocity, voltage is given 24 volt, and by solving that I get you will get 62.5, and approximate we can come with the answer. The correct answer will be the approximate. If you are going to do, we will get the 75 ampere. So current will be 75 ampere. By that we will get I. So my dear friends, ampere. So you have to be think like that. That was just a aptitude question. I don't think if it much more anything is required there. Just you have to be think. You need what? Electricity or current. How I can get the current? In the question voltage is given. So if anyhow I calculate the power, I can get the I, because voltage is known. So how I can get the power? Just area, velocity per second, how much metal is going to be melted out, how much it is going to be deposited out, and accordingly in the question here that data is given. That is that much of energy required to melt 1 mmq of volume of metal, and accordingly we can proceed. Right? I don't think, yeah, little bit calculation, but overall question is moderate. Now my dear friend, that question, next question is that the specific stiffness of material is defined as the ratio of mass to Young's modulus, density to Young's modulus, Young's modulus to density, Young's modulus to mass. A specific stiffness, my dear friends, right? Okay, what do you mean by the stiffness? Anybody? What do you mean by the stiffness? In the spring, you might have a study, or I will teach you in the class. Stiffness is basically, this is the spring, let's assume, and their stiffness is K. So what is K? K is load required unit deflection. What is stiffness? Load required to unit deflection. Suppose if deflection is 1, so K is equal to W, and you are going to apply the W, right? So energy required to unit deflection is known as stiffness. Even a spring has a stiffness, even you have a stiffness something, even that marker have some stiffness, even this marker have some stiffness, everybody have some stiffness. That different things, someone have less, someone have higher, that different things, but yes, everybody have a stiffness. So sir, in the, okay, getting, sir, what is a stiffness? A stiffness is basically energy required to make a unit deflection, that is called a stiffness. But sir, in the question is that given a specific stiffness. So a specific stiffness is always given by, my dear friends, E upon what? Rho. E is what? Young's modulus of elasticity. Rho is what, my dear friends? Density. So we can say, sir, C for Chennai is the right answer. Young's modulus to the density you are getting. This is called a specific stiffness, right? Even, my dear friends, just to, you can correlate one thing. Why it is called a stiffness? You know, suppose that is one of the object, and you are going to apply the load P. and this is a prismatic bar, load is axial. So what will be change in length? We can say, sir, PL upon AE, no sir, PL upon, this is change in length, PL upon AE. Suppose if everything is constant, PL, A, all are constant, so can I say L is 1 upon E proportional to Young's modulus? Yes. So what if Young's modulus is higher, delta L will be less. And what is delta L? Change in length. So it resists the change in length. The stiffness resists the change in length. And if you are going to divide it by rho, then you are getting what, my dear friends? Simply a specific stiffness. Okay. Coming to the next question. That is the next question. Which of the bearing given below is not suitable for axial thrust rod? Axial thrust rod, which one is not suitable? And you have an option: deep groove ball bearing, angular contact ball bearing, single rod tapered bearing, and option D is what, my dear friends? Simply we can see, sir, option D is given here, a straight cylinder, that thing, right? So what you have to do, my dear friends? See, if you talk about deep groove ball bearing, so it can handle radial as well as axial load, but axial capacity is what? Limited. A straight cylindrical roller bearing is designed to handle, see this, a straight cylindrical roller bearing is going to design to take a what? Axial thrust loads. Axial thrust load. What about deep groove ball bearing? My dear friends, they can take both axial as well as radial. Axial as well as radial load, both they can take. But if you talk about deep groove ball bearing, axial capacity is limited. This capacity is what? Limited. This capacity is what? Limited. If you talk about angular contact bearing, they can also take the axial as well as radial, but generally tapered roller bearing is going to be used here. So you have to be just keep in mind that straight cylindrical roller bearing is going to be used. Now coming to the next question, that was theoretical question, easy question it was. That is the good question, my dear friends. That is the good question, and we can solve that question. That question has been taken from strength of material, and you can do that. What the question is that a solid bar 50 mm diameter and 200 mm long consists of a steel and aluminum part joined together. A steel and aluminum part joined together. When axial force P is applied to the system, a strain gauge fitted to the aluminum indicate an axial strain of 800 micrometer per meter. Okay. What is the corresponding axial strain on the steel, assuming E of steel is given 200 gigapascal or E of aluminum of given, Young's modulus of aluminum is given 700 gigapascal. So how you can solve that? Just think, my dear friends. Now think like a scientist. Okay? Yeah. How I can think, sir? Nothing. Just draw the diagram what is given in the question. Don't be hesitant. Don't be hurry. Don't lose your patience. I can't solve. Like that question you will find. So how many questions we can left? So solve that question. Sir, a solid bar, right? So sir, this is a solid bar I have, right sir? This is the solid bar I have, and sir, this solid bar is made by aluminum plus of steel. Okay, this solid bar is made by aluminum as well as steel. Fine, that has been made by the alloy of aluminum and steel. In the question, sir, length is given, sir. This length is given in the question. How much, sir? This is given 2000 mm, means we can say the 2 meter. And sir, bar diameter is also known, sir. This diameter is also known, and this is how much, sir? 50 mm. Okay, sir. Fine. What is the okay? One force here, axial force P is applied. When an axial force P is applied to the system, okay, there is one strain gauge is fitted. One strain gauge is fitted. A strain gauge of the aluminum. A strain gauge of aluminum is fitted, and they are going to be read how much axial strain is going to be read 800 micrometer per meter. So what is the corresponding axial strain in the steel? What is the corresponding axial strain in the steel? You have to be calculate. Means, sir, in this question I have to be calculate the strain developed in the steel. Fine, that is the question. Now the thing is that, sir, how I can proceed in the question? the data that I have given. According to that, how I can proceed. My dear friends, first of all, you have to be calculate the stress. Calculate the stress. Once you get the stress, my dear friends, stress will be same. This is same material, so stress will be same for both aluminum as well as steel. Once I get the stress, that stress will be same for both the object, and from that stress I can calculate the strain, because you know, my dear friends, you can know now, sir, stress is proportional to strain within elastic limit according to the Hooke's law. So sir, stress is equal to this epsilon, right? So sir, in the question, if I talk about stress in the steel, in the aluminum, if I have to be stress in the aluminum, if I have to be calculate, so it will be E of aluminum plus this of aluminum, not plus, this will be multiply. So in the question, E of aluminum is known, sir. E of aluminum is known. How much, sir? 70 gigapascal is known, sir. So can I say, sir, sigma stress develop in that one, 70 giga, na sir? So 70 10 to the power 9 I am going to write. Aluminum is given how much? 800 micrometer. 800 micro means 10 to the power minus 6. Okay. From that we will get the stress value. How much it is coming out to be, my dear friends? If you are going to be solved, let me check. By solving that, this value is coming out to be 56 megapascal. By solving that, you will get the value is coming out to be 56 megapascal. Okay. So sir, and sir, you know, since both are same, so stress whatever developed in the aluminum, it will be equal to same stress developed in the steel. Developed in the steel, it will be same, sir. Okay, then that means the question becomes easy. So I can say, sir, stress developed in the steel is equal to 56 megapascal will be equal to E of steel into epsilon of steel. I have to be calculate epsilon of steel, right? I have to be calculate epsilon of the steel, the strain of the steel. It will be 56 into 10 to the power 6 upon E of steel is given how much? E of steel is given how much, my dear friends? 200 gigapascal. Fine. So just put the value 200 into 10 to the power 9. By solving this, I think this value is coming out to be, just solve that, and by solving that, this is coming out to be 280 micrometer per meter. 280 micrometer per meter. So it was an easy question. You have to be just brief on your concept. Don't be feared just by reading the question. Sometimes it's happened, my dear friends, a student just feared by reading the question. You have to be improved on that. Just read the question, believe on the concept that you have read, and try to apply that concept rather than fear how I can do that, I don't know. Just think and then proceed. That's why I used to say in the bar, not in the bar, in the ISRO exam, you have to be think like a scientist. You have to be positive mindset. When you are going to solve the question, your mindset should be positive. You know, that is a one play major role during the solving the question. Once you read the question and you have not a positive attitude, you don't have positive mindset, you will leave the questions. So attack on the question with positive mindset and try to do. I cannot say that will be become in only one day you can do like that. Yes, but continuously you have to be improving yourself, and at the last you will find yes, you are thinking like a scientist and you will get selected there. Right? Okay, my dear friends. So now coming to the next question without wasting your time. So see that next question. What the next question is there? Question are there. Two flanges are connected by a single bolt of nominal diameter 10 mm is preload to a torque of how much? 30 Newton meter. Okay. An external tensile load 10,000 Newton is applied to the joint. The torque coefficient is 0.15 and joint stiffness is given. The maximum tension you have to be calculate. Just give 1 second. Okay. So my dear friends, how we can do? Sir, two flanges are connected by single bolt. You have a two flanges. So it is connected by a single bolt of nominal diameter. So dia of bolt is given here. Dia of bolt. This is given 10 mm, right? And preloaded to a torque. Preloaded torque is given 30 Newton meter. Now see, an external tensile load 10,000 Newton is applied to the joint. Whatever joint is there, so there how much Newton? 10,000 Newton force is going to be applied to the joint. And the question torque coefficient is also given, my dear friends. torque coefficient, simply we can say KT, torque coefficient, KT is given, the value is given how much, simply we can say, okay, and stiffness constant is also given. The maximum tension in the bolt you have to be calculate. So my dear friends, maximum tension you have to be calculate in the bolt. So maximum tension is basically because of two force, Fi and Fe. Now first see, T, or we can say preload torque is always given by, preload torque is given by, preload torque is always given by, my dear friends, K2 Fi into D, KT Fi into D. What is KT here? What is the KT? Anybody can tell me? KT is torque coefficient. Now I am going to write KT is torque coefficient. Fi is initial preload force, preload force, and D we can say the nominal dia. From there, can you calculate Fi? In the question, preload torque is known, so T upon KT into D. In the question, everything is known. Torque is given how much? 30. KT is given 0.15. and D is given 0.01. By solving that, we will getting Fi. The Fi is coming out to be, this is called what? Fi is called initial preload. It is coming out to be, I think, 20,000 Newton. Yes sir. So is this our answer? No, my dear friends. There is a load is also acting. Load is also acting on the bolt, and this load is how much Newton? 10,000 Newton is also there. If it not would be there, then I will go with the option B. If there is no like that, then I can go with the option B. But okay, but in this question, load is also there. So my dear friends, what I have to do now? Now addition force on the bolt due to external load P. Addition force due to external load P, it is given by C into P. This is external force due to application of load P, where C is known as, my dear friends, C is known as joint stiffness constant. Stiffness constant, joint stiffness constant, and that value is given how much, my dear friends? I think it is given 0.2. P is applied load, this is applied load. So from there we can say, sir, Fe is coming out to be how much, sir? 0.2, and applied load is given 10,000. Yes sir. So by that you are getting how much? 2,000 Newton is coming out to be. So what is the total force? Total force we can say, total force F total is equal to F of I plus F of E. It is coming out to be 20,000 plus 2,000 is equal to how much thousand? 22,000. 22,000 is your answer. So what the answer is, dear my dear friends? 22,000 Newton is your answer. So C for Chennai is the right answer. So as I told you, you have to be think, then only you could be able to solve the question. Now coming to the next question. See, that is a great question, yeah, really mind-blowing question. Mind-blowing question it is, and real life incident like that question is going to be asked in ISRO. If you are by hearting the things, you don't know the exact cause, then yes, you will find difficulties to solving that question. Read that question, my dear friends. You have 1 second of time. What you can say? See, in an accident site, tire mark shows that a car was traveling along a straight level street skid for a total distance of 23 meter. Well sir, after the brake applied, the coefficient of friction between the tire and the road estimated to be 0.5. Fine sir. What was the probable speed of car when brake was applied? It was a real life situation. You are driving your bike or car, suddenly you are going to apply the brake, and after the application of brake, still your vehicle is going to move how much meter? 23 meter. So the question is that, what was the speed when suddenly brake is applied? That was the question, and really beautiful question it was, and you have to be think like a scientist, then only you could be able to solve the question. Really good question, na? You are, suppose you are driving a car, suddenly something is coming and you are going to suddenly apply the brake. Even application of brake, there is a skidding, and due to the skidding, your vehicles or your car is going to move the 23 meters. So now the question you have to be calculate, what was the speed when the brake was applied? That you have to be calculate. Yes sir, getting sir. So how I can do that, sir? How I can do? What? How you can do, my dear friends? Anybody can tell me? What will be answer? Can you try? Can you try? Okay. See the question. So, sir, in this question, just listen. First, leave the data, write the data, then start thinking. Rather than leaving the question, write all the data. What the data, sir? What the given data, sir? In the question, in accident site, the tire makes mark shows that car was traveling along a straight level street for a total distance of 23 meters. So after application brake, how much meter it is going to move? Sir, it is going to move for the 23 meter. Fine. After the brake applied, the coefficient of friction between the tire and the road, suppose that was the road and that was your vehicle tire. So here coefficient of friction is known in the question, and that value is coming out to be how much? The coefficient between tire and the road estimated to be 0.5. This is coming out to be 0.5. What is the probable speed? So what was the probable speed when the brake is applied? That one. So how you can do that, my dear friends? Now just think out. Sir, just say, when the brake is applied, na sir, when the brake is applied, after that vehicle is going to be stopped. So which one force is responsible to stop the vehicles? Obviously, sir, frictional force. If there would no be frictional force, body will continuously going to be skidding to the infinite length. Because of that friction force, body is going to be stopped. Yeah, right, sir. Right, sir. Right. If there is no no roughness is there, no friction is there, even if you are going to be suddenly apply the brake, your car is going to skid. For how long distance? Infinite distance they will cover if there is no roughness, no friction. Yes, sir. Right. So, sir, the thing is that the vehicle is stopped because of which force? Obviously because of the frictional force. Right, sir? So what is the frictional force, sir? Sir, frictional force I know. Frictional force is what? Mu into n, sir. And suppose this is a car. So what will be? In the upward direction, and in upward direction you can apply the n, and downward is what? Here you can say mg. So frictional force is equal to what, sir? Mu mg. Right, sir? Frictional force equal to what, sir? Mu mg. Right, sir? In the question m is known. Okay, not known, no need to worry. Okay, fine, getting, sir. Sir, now tell me one thing, sir. Once I suddenly apply the brake, so it is accelerated or retarded? Obviously, sir, it will be retarded, sir. It will be retarded. Velocity decreases, so it will be retarded. So can I write frictional force will also equal to what? M into A. Yes, sir. Now tell me, from there, can I say M into A is equal to mu mg? Right, sir, I can say. So, sir, m will get cancelled out. What will be acceleration? It will be mu into g, sir. In the question, mu is also known, g is also known. Now the question is that why I am going to be calculate u a, sir? Why I am going to be calculate a? Yes, my dear friends. My dear friends, in the question, s is known, your final velocity is known, and you have to be calculate initial velocity. Right? Yes, sir. So can I write v square equal to u square plus of 2as? In the question, final velocity is 0. If I get the a, question in the question, this displacement is given, can I calculate u? Yes, sir, I can, sir, I can. That's why, my dear friends, I have to be calculate the a. And a, how I can calculate? F is equal to mu mg, and that force is only applicable here to retard the motion. So F equal to ma, I can say from the Newton's second law. Yes, sir, getting, sir. So from there we can say what the value of a is coming out to be, my dear friends. Just put the value. A will be equal to mu is how much? It was 0.5. Let me check. So how mu it was? Okay, 0.5. Okay, 0.5. And simply, yeah, in your exam calculator is not there, so you can use the G10. Right? Just use 10. So it is coming out to be 5 meter per second square. Now put the value is there. So, sir, it will be 0 equal to u square plus of 2, but a will be minus. A will be minus. Why, sir? Because it is retarded. So minus 5 into s. So from I can say, sir, u square equal to 2as, u equal to 2a 523 under bracket under root, and by solving that you will get approximate how much it is coming out to be by solving that. 54 point something. By that you will get u is coming out to be 15 point something. We can check out. This is meter per second, but in the question it is given in the kilometer per hour, because a speedometer that is connected in your vehicle, it shows in the kilometer per hour. So option is given in the kilometer per hour. So let us convert that in the kilometer per hour. So this is meter per second. Simply we can say sir kilometer, na sir. So 15.2 kilo means kilometer. So it will be kilo, na. So 1 upon 1000. But this is second. To convert in the hour, just multiplied by 3600. That was 1. And by solving that, how much it is coming out to be? Approximate 54.036 kilometer per hour, which is coming out to be 54. What answer is there? Yes, the answer is A for apple. The answer is what, my dear friends? A for apple. So what was the approach to think? What was the approach to think? First you have make a draw, draw whatever has been given in the question, believe on your concept, and you have must positive attitude. First you have to think, okay, this vehicle, when the brake is applied, after the skidding it takes place, so vehicle will stop only because of the friction force. Friction force equal to mu n, this is equal to mu mg, and this will be also equal to ma. So A. Why I have to be calculate A? Because sir, I have to be calculating in the question u, initial velocity when brake was applied. So you know sir, it is given by v square equal to u square plus up to s, but here plus will not be there because it is not accelerated, it will be retarded. So minus A is coming. Once I get the A, I can calculate. So from there I have get the A, and accordingly I have get the answer. So like way we have to be think, rather than ki oh just seeing the question and oh yaar tougher question I can't do. No, you can, you have a potential, but you must have to be positive attitude. That most important in the exam. Coming to the next question, my dear friends, that is the next question, and yes, that is also great question here. Really ISRO is going to ask a great question, and you know why? Because you are being a scientist, you have to be thinking, you have to be think. See the question, great question, it was a really excellent question. The question is that in a solid cylinder, if a solid cylinder, thin hollow cylinder and a sphere, fine, all with same material and having same outside diameter, allowed to roll down in a same inclination without sliding. Fine sir. All surfaces are having same coefficient of friction. What is the order of the bodies reaching the bottom? All reach together, solid cylinder, sphere, thin hollow cylinder, sphere, solid cylinder, thin hollow cylinder, thin hollow cylinder, solid cylinder, and sphere. That is the question. What will be the answer? So just think the question first and start thinking. Okay sir, I have to be start thinking. A solid cylinder, suppose sir, like that, this is the like that, okay, and here three things. One is solid cylinder, a solid cylinder, thin hollow cylinder, this is a sphere. One is solid cylinder, one is hollow cylinder, okay, like that, having outside diameter allowed to roll. Now these all are allowed to roll over that one. Suppose if I am going to leave all these three at the same time, so now the question is that, which will come fast at here, which will come faster, or which will come first at that their level? That is the question. You know, in this question what is happening, most of the student is making option A, my dear friends. I have seen in the previous, whenever I am going to take in the class, they are going to be answer A, but that is wrong answer, my dear friends. This will be only when if the rectangular block is there and mass different. If in this situation we cannot say it will be the answer. So first of all sir, now tell me which will come here fast. Sir, I can say the body having high acceleration will come faster, because you know V is equal to U plus 2AS. Okay, so sir, U is 0 for all the body. So sir, S is same, that distance is going to be travel, so S is same. So sir, any body have A will be higher, it have higher velocity, so it will come fast here, it will come first. Sir, right sir, A will be higher, it will come first. Now the question is that how I can calculate the A in that case, my dear friend, how I can calculate A? So my dear friends, I want to just give one formula to calculation of A in this situation. If you can remember, it is well and good, otherwise no need to worry. Last conclusion I will tell you that you have to remember G sin theta upon 1 plus I upon mr square, that is the acceleration that you can get, G sin theta upon that one. Now my dear friends, I is what? Moment of inertia. So you know moment inertia for all, what will be I for solid cylinder, it will be half mr square. What will be I for hollow sphere? I for hollow sphere, do you know anybody? mr square. And what will be I for sphere? Sphere, try to remember, it is 2 by 5 mr square. Now put that value here, and by solving that we will get, my dear friends, by solving that, just put that value there, and by solving that we will get A of solid sphere, A of solid is coming out to be 0.66 g sin theta. In case of A of hollow sphere, hollow cylinder, not sphere, it is coming out to be, I think, how much, 1 upon 2.5 g sin theta. And if you talk about A, in case of sphere, that value is coming out to be 0.7 g sin theta. Now tell me, my dear friends, which have higher A? So sir, sphere have higher A for the same mass, everything. So sir, first of all, I can see here A of sphere is high, so it will come first. After that, A of solid will come first. After that, A of hollow. So material having higher A will come fastest. So the correct answer will be what, my dear friends? Here we can say, sir, first of all sphere, after that solid cylinder, after that thin hollow cylinder. So correct answer will be C4, Chennai. And yes, that was the good question. Generally a student is going to be stuck in that type of questions. But as I told you, you have to thinking capability like a scientist. All the problem, you have much positive attitude, easily you could be able to solve that question, all that type of question, nothing tougher. Chalo, come to the next question. Yeah, that is the next question. A 0.2 mm, okay, that is the question of the gate, that type of question has been asked. That question is related to gate. A 0.2 mm thick strip is bent and laid over a frictionless pulley of 25 mm diameter. If E is 100 gigapascal, the maximum stress in the strip, and these all are given. My dear friends, easy question. You can see. Suppose that is the one of the ruler, or you can say pulley. Over that, that is the belt or rope, whatever you can say. Don't go on my diagram, but just listen, try to understand the visualized things. That is the diagram. Okay, sir, in the question thickness is given, sir. In the question that thickness is given. Yes sir, that thickness is given. How much, sir? 0.2 mm, sir. 0.2 or 0.02? Oh yes sir, 0.2 mm is given, and E is given here, sir. How much? 100 gigapascal. The maximum stress. So it is bending, sir. What is the equation of bending? Anybody can tell me? Anybody can tell me equation of bending? Yes, you can. Yeah, you are engineer, sir. M upon my engineer whom? E upon R sigma B upon Y. That is the equation of bending, sir. And in the question I have to be calculate sigma maximum, sigma B I have to be calculate. So sir, can I say? What can I say? Sir, in the question E and R, radius is known, sir. In this question E and R, so can I say sigma B is equal to E Y by R? Yes sir. So sigma B, what will be Y? Sir, this is, so there will be one neutral axis, na yaar? Yeah, there will be one neutral axis. Yes sir, this is neutral axis. This will be the neutral axis, and from the neutral axis what will be Y? Outer fiber, na? Maximum stress will be outer fiber. Either it is outward or inner. It will be on the outermost fiber. So either there or there. So you can say Y is equal to how much, sir? 0.1. Y is equal to 0.1 mm. Just put the value and you will get the answer. Sigma B is coming out to be, in the question is known there, how much, sir? 100 giga is given, sir. So 100 giga, so 100 into 10 to the power 9 into Y. Y is 0.1, na? I am going to write there. I am going to write here. Sigma B is equal to 100 into 10 to the power 9 into Y is given 0.1. Okay, make in the 0.1 mm, or answer is given in the megapascal. Okay, no problem. 0.1 mm, 0.1 into mm will get cancelled out because in the denominator also mm is coming out to be upon what, r. So 12.5 my dear friends, because diameter is given na here, diameter is given na, diameter is given or r is given, frictionless yes, diameter, so 12.5. just solve that value my dear friends, just solve that value. By solving that, I think how much it is coming out to be my dear friends, by solving that we will get the values coming out to be 800 megapascal. 800 megapascal is coming out to be answer, and it was I think easy question and the student can do that, but the thing is that they must have to remember the bending equation. If they don't know how to use the bending equation, they cannot be able to solve that one. Okay my dear friends, great, you guys have really lot of patience. Good. Now if you have a lot of patience, so I am coming to the next question, and yes, this is again a good question, but before that I am going to take another question, then I will come on that question. Okay, let's move with that question. Where is the question? Okay, let's start with the same question, then I will come. One important question is there, the concept that I have discussed just now, it is related to the same question. I think it is very far, so let's move in the sequential manner, no problem. So that is the next question on your screen my dear friends. I am going to be little bit zoom out, right. The question is that a 500 diameter solid shaft is welded to a flat plate all around by the fillet weld of 4 mm leg size as shown in the figure. Fine. If the allowable shear strength of the weld material is 100 megapascal, the maximum approximate torque in Newton meter that the weld joint can sustain under pure torsion, and the option you have 500 pi upon root 200 1000 pi upon root 2, and since calculator is not allowed, that's why they have left the option in that format, and you have to be answer. See how we can solve that my dear friends. Just start thinking, don't be trapped in the language of that question. Okay sir, a 50 mm diameter solid shaft welded to a flat plate. This is the flat plate my dear friends, oval they like that. Suppose that is a flat plate, upper that you are going to weld that object now. So this is something like that, you are going to be weld it like that. So a 50 mm diameter solid shaft is welded to a flat plate all around by fillet weld of 4 mm leg side. This is joint is what, fillet joint, and the leg size is given 4 mm. If the allowable shear strength of the weld material, the maximum shear strength that weld material that they can sustain is given 100 megapascal. Well sir, the maximum approximate torque, no, you have to apply the torque there. We can see here one torque is applied there. Can you anybody tell me what is difference between bending and torsion? What is difference between bending and torsion? When the torsion is coming my dear friends, whenever, suppose that is the plane of cross section here, this is the cross section, whenever the movement along the cross section of the object, suppose that is the cross section and movement is like that movement, then it produce twisting. But if the movement is in anywhere in the longitudinal axis equal and opposite, then it gives bending, then it gives what my dear friends, bending. So now see my dear friends, we can see sir in the question here the maximum approximate torque welded joint, in the question you have to be calculate the torque. So what will be the equation? First you have to be know what will be the equation of twisting. So simply we can say sir, I know T by J G theta by L equal to tau by R, right, tau by R, that is the equation of torsion, or you can say twisting equation. Sir in this question I have to be calculate the T, in this question tau is known sir, R is known, so can I say T is equal to tau J upon R? Yes sir. And in the question tau is known sir, in the question shear stress is known sir, maximum that they can withstand 100 MPa is known sir. In the question radius is also known, how much sir, 50 mm diameter, that means radius is also known 25 mm. But sir if anyhow I am able to calculate the J, this is called polar moment of inertia. J is called is what my dear friends, polar moment of inertia. If anyhow I am able to calculate the J, I will get the answer. That is only things you have to be do. That's why when read the question, now the question is that how I can calculate the J. So my dear friends, polar moment of inertia for circular ring J is given by a r square. In the question, sir, r is also known. Sir, now the question is that I have to be calculate the area of the weld. So what will be the area of the weld, my dear friends? Area of the weld will be, A is what? Area of weld. Area of weld, it is given by throat into weld length. What? Throat into weld length. Weld length, na, simply we can say, हाँ sir, weld length. So what will be throat? What will be throat, my dear friends? Throat is always given by T is equal to H into 1 by root 2, or we can say H by root 2. H is given how much? Leg height is given here in the question. Leg weld, fillet weld 4 mm leg. So H is known here, sir. How much? 4 mm. So it will be 4 upon root 2. Leave, don't solve that one, because ultimately in the option you have to be calculate in the form of a root 2 itself. So leave that one. Okay, so thickness is known. Sir, what will be A? What will be area? So area will be, sir, T into what? Weld length. So weld length, it will be pi d, na sir. Weld length, suppose this is circular, na yaar, here is a circular, na. So what will be length? Circumference is the, simply we can say circumference. If you are going to be cut them, and I will tell you what will be the length. So circumference will be what? Pi d. Circumference will be the pi d. So just put that value here, pi d. Sir. So by doing that, I will get some. So T into pi d. So thickness 4 upon root 2, and pi, leave the pi, and d is given how much? 25 or 50? 50, na. D is given 50, na. Yes sir, 50 is given. So from there, just put the value 50. So A is coming. What will be tau? Tau will be a r squared, sir. So A is 4 upon root 2 into pi into 50. R is given again how much? Simply we can say R is, sir, 25 mm, na. Yes sir, 25 mm there squared. Now put that value. Yes, here see my dear friends, in this question we can say, so lot of calculation is there, sir. Without calculator, now it will be very tedious to solve the next step. Now if no calculator is there, putting that value and you are going to be cancel out, obviously it will be very, very complicated, and no. So not all data for, so that's why my dear friends, I used to say little bit work on your calculation speed, because in the gate or in the college day, all engineers are being habitual to use the calculators. Even they will ask what will be 4:2, they are going to use the calculator. So if you are totally dependable on the calculator, so little bit work on that and try to solve the question without calculators. That will help you a lot in the exam. Otherwise my dear friends will stuck like that. They type, yeah I know that is a complicated calculation, but you have to do na yaar. How many questions we can left for the calculations? If you have to be selected, you have to do something different na. So do that yaar. So my dear friends, I have answer because I have used this, I have made all the calculations, and by solving that, T is coming out to be, put this value, it is coming out to be 500 pi upon root 2. 500 pi upon root 2, it is coming out to be answer by putting all that data. So the 500 pi upon root 2, it will be the A will be the coming to the right answer. Great. Okay. Coming to the next question. What is the revolving joint of the robot called? So that question is a theoretical question, my dear friends. Simply we can say, right, this is called is what? Revolving joint of the rod is known as, simply we can say, T joint. So simple, theoretical is that, you have to be just remember. Now my dear friends, that question is again has been taken from the subject, you can say machine design. In the class I used to discuss, and hopefully that was direct straightforward question, and the student who have prepared, they can do that, no problem, they will not find any problem. If anyone have prepared for the exam, na, they will not find any difficulty in that type of question. The diagram below showing the various criteria for a fatigue failure. Which option is the correct representation of these criteria? Subscript E, Y, U represent endurance, yield, and all that the value is given there. My dear friends, most conservative theory is known as Soderbergh theory, right? So 1 will be always Soderbergh. 1 will be Soderbergh. So sir, answer B and D can't be, sir. No. After that 2 will be the Goodman and 3 will be the Langer line. Now 2 will be the what, my dear friends? 2, this is called Goodman, and third one is called Gerber parabola, Gerber line. So A will be the right answer. 1 Soderbergh, 2 Goodman, and 3 is the Gerber parabola. So A is the right answer, my dear friends. Huh? What is the option A? Huh. So easy question it was, easy, really it was easy question, and everyone who have did that, they can solve that. No, that is the next question. Question is that a 20 mm diameter aluminum rod is turned to 19 mm diameter in a single pass. Well, if the axial speed of the tool is 200 mm per minute, okay, and the spindle rotate at 600 rpm, the material removal rate nearly, and the option you have 61,000 mm3 per minute, 12,250 mm3 per minute, 3050 mm3 per minute, 9150 mm3 per minute. That the option you have, my dear friends. How you have to be proceed? See, a 20 mm diameter aluminum rod is turned. This is a turning operation, has been taken from the production engineering. One topic you might have gone through, metal cutting. So that question has been taken from the metal cutting. Specify if you want to be, you can say from the turning operation, right? Okay. So a 20 mm diameter aluminum rod is turned to 90 mm diameter in a single pass. Okay. So my dear friends, thing is that suppose that initially that was your aluminum rod and the diameter is given, my dear friends, 20 mm, right? The diameter is given 20 mm, and you are going to be use here one turning tool operation, right? That is the turning you are going to be used there. After turning, kahani is happening something like that. Now this is the things, right? Okay, not okay, that has been turned out, turning is done, that is your tool. Okay, that is your what, my dear friends? Tool. Okay, fine, that turning operation. And you know, my dear friends, in this direction this velocity is called what, my dear friends? We can say feet. And in the question what you have to be calculate? You have to be calculate, simply we can say m, what, material removal rate, na? The material removal rate is nearly. So what will be material removal rate? First of all, tell me, my dear friends, what will be depth of cut? So this is depth. What will be depth of cut? If I will ask, D is called depth of cut. Depth of cut. Let's assume, my dear friends, this is R1. This is what, R1, and this is what, after the cut, this is R2. So depth of cut will be what, my dear friends? Simply we can say, sir, R1 minus R2, or you can say D1 minus D2, or you can say the D1 minus D2 upon 2, or we can say R1 minus R2. So it is coming out to be R1 is 10 and R2 is how much? 9.5. So it is coming out to be 0.5. Okay, what will be material removal rate? What will be the material removal rate? So we can say, sir, material removal rate is will be simply area into velocity. Always, yaar, whenever you have to be require rate, na, material removal rate, discharge, area into velocity. So what will be area, sir? Pi R1 square minus of R2 square. What is the velocity? In the velocity, this is given, na, how much? 200 mm. How much? 200 mm per minute. If the axial speed of the tool is how much? 200 mm per minute, that means in 1 minute they are going to move how much? In 1 minute they are going to move 200 mm. So 200 mm per minute. So leave in the mm per minute, just put the value 200 mm per minute. Ultimately you have to be get the answer in the minute, so leave that. Now put the value pi, what will be R1, my dear friends? 10 square minus of 9.5 square into 200. Now little bit calculation is there. So pi, we can say, sir, 100, 81, and by doing that we will get 90.25. Little bit calculation, as I told you, you have to be do, you cannot skip. And by solving that we will get 6126 mm3 per minute, mm3 per minute. But in the option that is not present, so accordingly we can say in the option it is coming out to be 6100 meter cube mm cube per minute. So that is the material removal rate, my dear friends, and it is coming out to be how much? So what will be answer? 61. So whenever, see in the option mm cube per minute, now see from the option we can guess mm cube per minute. Mm cube means volume, per minute means volume is what? Area into velocity. So from the option you can think, okay, something I have to do the area into velocity, then only I can get the mm cube per minute, right? So area into velocity simply do na yaar, don't think much more, huh? Right? In the go through the option, I know, okay, suppose you don't know, sometimes it's happened, but through the option we can answer. We can think, sir, all option are mm cube per minute. How it will coming, sir? In the fluid mechanics you used to teach me, sir, discharge meter cube per second. Okay, minute is there, no problem. So area into velocity, sir, area is that, na sir, okay, that will be turning, na sir. So area will be what? Area we can calculate whatever is turned out in a single pass that has been completed. So final minus initial, right? And velocity is given 200 mm per minute. That means in 1 minute they will move 200 mm. That is axial velocity. Now just put that value and off, and after that we'll get the answer. No problem is there. Yes, that is the, my dear friends, really good question. I appreciate that question. The concept has been used in that one, and I will tell you, you can solve that question fast. If you can solve, take the attempt, then rest we will see. See, okay, I know, by watching the diagram, a student is getting feared. Okay, sir, how I can solve that question? Just use the concept and your mind, and yes, positive attitude. These three things: concept, mind, and yes, positive attitude. If these three things you have, if anything is not there, you could not be able to solve. If you have these three things, very easily you could be able to solve that question. Okay, sir. So what that thing is, sir? First read the question. A small ring Z carry vertical load A of mass 27.3 kg. A mass is given, my dear friends. Mass of A, or we can say the mass of A is given here 27.3 kg. Well, by two strings Z x and ZY. So that is Z. So Z is Z x and ZY. A string XY carries a load at B XY. A string XZ, not Y, carries load B at its free end through a frictionless pulley. Fine, here we can see there. Find the value of B round to the nearest integers if the string is stable and the configuration shown in the figure. That the diagram you have. Now start thinking, what the concept behind that, my dear friends? In the classroom, I used to say always that one thing you have to be keep in mind, my dear friends. If there is a single string, na, tension will be same throughout. Just start thinking, sir, in this question I have to be calculate the find the value of W. Sorry, M means I have to be calculate the mass. Mass, na? Yes, I have to be calculate the mass of B. Sir, I have to be calculate the mass of B. Okay, sir. Right. Yes, sir. Now I start thinking how I can do, sir. Okay, start thinking how I can do that question, sir. Sir, I have to be calculate mass of B. Right. If I come to the point, na sir, so in the vertical direction, M B into G will act, sir. Right. And upward direction, the one tension is coming, sir. One tension is coming. If anyhow I am able to calculate that tension, so I can say, sir, this T is equal to MB into G. Yes, sir. Right. And anyhow, if I calculate that T, sir, G is known, I will get the MB. Right, sir. That is only approach I have to do. Now the question is that how I can calculate that tension, yaar? Sir. Right, sir. If you see 3, so ZY and this is a single rope, na sir? Sir. Single rope. So in a single rope, tension will be same everywhere. Right, sir. In a single rope, tension is same everywhere. So, sir, let's assume I am going to be tell this is tension T1, this is tension T2, right? And that is the mg. We can say here the weight is acting here. Mg is how much? 27.3, and G take here 10. G you can. I have used the calculator, so I have used 9.1, but in the exam calculator is not there na, so you can use the 10. Okay, I have used the calculator, that's why I put the 19.8 or 9.8, sorry. Now sir, what I have to do? Sir, body in the stable, na sir. In the question it is given that body in the stable equilibrium. So can I say, sir, if the body in equilibrium, so can I say summation of all the force in x direction is 0 and summation of all the force in y direction is 0? Huh, sir. Then only body will remain in the equilibrium and statics condition, right, sir? So now break the component in the given diagram. Suppose this is T1. So what will be their component here? What will be their component? So this one will be T1 sine of 45, and sir this one will be the T2. So T2 sine of 60, sine of 60. So sir, can I say, if I am going to use equation summation of all the force in x direction 0, so can I say what, minus T1 sine 45 plus of T2 sine 60 is equal to 0? Yes sir. So from the equation I can say कि सर T2 sin 60 is equal to T1 sin 45. Let's assume equation number first. Let's assume it is a equation number first. Now sir, can I say Fy is equal to also 0, sir? Fy is also equal to 0, sir. Summation of the force in y direction is also 0, sir. So what will be y direction? So we can say, sir, T1 cos of 45, T1 cos of 45 plus T2 cos of 60 in the vertical direction, yeah, minus 27.3 into 9.81 is equal to 0. So can you get the equation number 2 from there? We can say, yes sir, T1 cos of 45 plus of T2 cos of 60 is equal to 27.3 or into 9.81, whatever is coming out to be 20.3 into 9.81. So my dear friend, that is equation number 2. So from the equation number first and 2, can you get relation between T1 and T2 or not? Yes sir, I will get the relation by the solving the equation T1 and T2. By solving the equation first and second, I will get the relation T1 and T2. Put that relation in there, and after doing that, my dear friends, I am coming to the right there, that value. After solving that, the value is coming out to be T1 is equal to here. T1 is equal to coming out to be 1.225 T2, and further by the equation that one, put that value in the above equation, and by putting that value, we can say the T2 is coming out to be how much? 196.05 Newton. 196.05 Newton is coming out to be. And now my dear friends, use that concept there. T equal to mg into b. So T2, this is your, my dear friends, T2 because of single string. So can I say T2 equal to mb into g? So what will be the mb? So it will be 196.05 upon 10, or you can say 9.81, but 10 will be g. By solving that, the value is coming out to be approximate 19.98, or we can say the 20 kg. So the what answer is coming out to be, my dear friends? It will be the 20 kg. So what the answer? Bombay is the right answer. So that's why, my dear friends, there is nothing that you don't know. You know all the things, but where you have lag? You lag by applying the concept, or some hypothetical pressure appears on you that you cannot solve the question and you have left it. So if there is anything new that I have teach you, but the concept that you know from the very earlier, same thing I have used there. That's why practice and positive attitude is most important in your selection, my dear friends. Really most important. Your positive attitude is most important here. So simply I have just do the balance, but yes, one concept is there. In a single string, the tension will be same throughout. That is only one concept that you have to remember. Rest thing will come automatically, right? Okay. So my dear friends, that is the next question. And try to solve that question. You have a few seconds. The question is that an aluminum ring of mean diameter of 5 meter at ambient temperature. Okay, an aluminum ring of mean diameter of 5 meter at ambient temperature is dipped into a liquid nitrogen bath. Okay, liquid nitrogen, you know na, temperature is very less here na, liquid nitrogen very less will be temperature. Okay, what will be the mean diameter of the ring in LN2 bath, nitrogen bath? Okay, the coefficient of linear expansion of aluminum alloy in temperature range may be taken as 20 into 10 to the power minus 6 per Kelvin. Ambient temperature may be taken as 24 degrees Celsius. Boiling temperature of liquid nitrogen is coming out to be 77 Kelvin, and that you have to be used. You know, my dear friends, see, you have a aluminum ring of mean diameter 5 meter. So suppose that is a aluminum ring you have, my dear friends, right? And the mean is here, you can say 5 meter. Well, temperature, now you are going to be deep in the nitrogen. You know, nitrogen temperature very less. So you are going to be deep now in the bath in which nitrogen content is there. Cryogenic engineering you might have listened, no? Like that. So nitrogen content is there, right? And in the question, the coefficient of linear expansion alloy temperature may be, so alpha is also known, my dear friends, how much? 20 into 10 to the power minus 6 per Kelvin, or you can say Kelvin power minus. Ambient temperature may be taken as when it was in the atmosphere, their temperature was 24 degrees Celsius. In the question it is mentioned that when, since this aluminum was initially in the ambient, so it was 24 degrees Celsius. So what the question? Mean diameter is itna. What will be the mean diameter of ring LN2 bath? Now what will be the mean diameter after putting in that one? What will be the mean diameter when I am going to put in that one? So simple we can do, my dear friends. Can you do? Yes. So what will be, let's assume, what will be T naught, final temperature? What will be T naught, my dear friends? So we can say, sir, T naught is coming out to be 24 plus 273. So by solving that, you will get 297 Kelvin. 297 Kelvin. Okay, yes sir. Sir, what will be change in dia, sir? Okay, what will be delta T? What will be delta T? Delta T we can say, sir, this is 297 and this is 77, right? So what will be delta T? Final minus final temperature is 77 and initial is 297. This is the final temperature, boiling temperature liquid nitrogen 77 na. So final when you are going to put them, so it will be final temperature 77, initially was 297. So by solving that, how much is coming out to be? Minus 220 Kelvin. Okay, why I have used that, sir? Because I know change in diameter is given by D naught into alpha into change in temperature. So sir, this is D naught. In the question it is given out 5 into 20 into 10 to the power minus 6 or into minus 220. Now it is going to be contract, not expand, because temperature is decreases, right? So change in diameter, by solving that, this value is coming out to be how much? 0.02 meter. So you can say, sir, what will be final dimension? What will be the final diameter? In the question, final diameter is calculated, you have to be calculate. So simply we can say, sir, di minus d naught is equal to change in diameter. So in the question, change in diameter is known, sir. So df final diameter minus that one. So our final diameter will be do plus of change in diameter. So do is 5 minus of 0.022. By solving that, we will get 4.978. So the answer will be 4.978. 4.978. 4.978. Very close answer. Such a close answer should be there without calculator. Very close answer is there, my dear friends. So simply even now you can eliminate the option. C can't be. Why? Because temperature decreases na. So it is not going to be expand. It is going to be contract. Because temperature decreases. So it is going to be contract rather than increasing. Okay? Getting? So that thing you have to be just keep in mind, my dear friends, how you have to be proceed. Okay, and in this question, the main thing that you have to be just here keep in mind, it is going to be, you know what, it is going to be, simply we can say, sir, it is going to be cooling down. So if you are going to be cool anything, their diameter decreases rather than increasing, right? So by that we also can make a conclusion. This is called cryogenic, fuel also cryogenic, the thing which exists at a very low temperature. Cryogenic concept is also there. So okay, that is the next question, my dear friends. A journal bearing of radius r1 and radial clearance c1 has a Summerfield number s1. Another journal bearing of radius r2 and radial clearance c2 has Summerfield number s2. All other parameters remain same for both the bearing. If r2 equal to 2r1 and c2 equal to c1 upon 2, then s2 upon s1 you have to be calculate that things, my dear friends. You have to be calculate that things. So that question has been taken again from the machine design. One topic is there, bearing. So that question has been taken from the bearing. The question very simple. A journal bearing of radius r1. Okay. See, my dear friends, suppose that is the your bearing, right, and that one your journal, that is the O node, and this is their center, and this gap is called clearance, my dear friends, right. This is called radial clearance C1. This is called radial clearance, right. So journal bearing and their radius is r1 in the question, and radial clearance C1, and Summerfield number s1. Their Summerfield number is s1. Fine. Another journal bearing, there is another journal bearing, right, of radius r2, radial clearance. Now this is the bearing. Now their radius is r2, and let's assume this is their center, this is their center. Now their clearance is given in the question c2. Well, another journal bearing of radius r2 and c2 has a Summerfield number s2. Now their Summerfield number is what, my dear friends? s2. All other parameters remain same for both the bearing. Rest parameter is same. The only condition, if in the question they are going to be say, sir, r2 equal to twice of r1 and c2 is equal to c1 upon 2, then the relation you have to be calculate, sir, I have to be calculate s2 upon s1, I have to be calculate. Bas. That is the question. Now start thinking. First of all, you have to understand what is Summerfield number. If you don't know Summerfield number, you cannot step in single step now. Right. So first of all, you have to know, sir, what is Summerfield number. So Summerfield number is given by S is equal to mu n r square upon pc square. That is the Summerfield number is given by mu n r square upon pc square. What mu? Mu is dynamic viscosity, or you can say coefficient of viscosity. N is rpm, revolution per minute, or you can say rotational speed. R is journal radius, P is bearing pressure, C is radial clearance. C is here what? Radial clearance. Radial clearance, and R is what? Simply I can say R is what, my dear friends? Journal radius, journal radius, journal. So now see, my dear friends, now we can say, sir, in the question it is saying that only radius and clearance is going to be changed out. Rest parameter are same. Rest parameter are same, means mu and p, that all are same. Only radius and clearance is going to be changed. So can I write? Can I write like that, my dear friends? Tell me. S is equal to something constant, r square upon c square. Right, sir? Yes. So can I write S equal to proportional to r upon c whole square? Why not, sir? Yes, r upon c square, right? Can you say? So can I say, sir, S1 C1 upon R1 whole square is equal to S2 C2 R2 whole square? Yes, sir, I can, sir. Why not, sir? Obviously I can. What I have to be calculate, sir? I have to be calculate S2 upon S1, right? S2 upon S1 I have to be calculate. So S2 upon S1, what the value is coming out to be, my dear friends? S2 upon S1, right? S2 upon S1 or S1 upon S2? What need to be calculated? S2 upon S1, right? So it will be what, my dear friends? S2 upon S1. So it will be C1 upon R1 square into, we can say, sir, R2 upon C2 square, right? So just put that value here. Simply we can say, sir, C1 upon R1 R2 upon C2, just put the value and there squared, put the value by coming that it is coming out to be 4 chi squared, it will be 16. So simply we can say, sir, S2 equal to 16 times of S1. S2 equal to what, my dear friends? 16 times of S1. So what the correct answer? 16. Yeah, the ratio you have to be just calculate, not you have to multiply, you have to be just calculate the ratio, and after that we will get the answer. That ratio it is coming out to be, right?